On February 4, 2025, the USS Preble DDG-88 made headlines by unveiling the Helios high-energy laser with integrated optical-dazzler and surveillance laser weapon system, a significant advancement in naval warfare technology. Developed by Lockheed Martin, Helios represents a transformative leap from theoretical directed energy weapons to practical applications on the battlefield, demonstrating the U.S. Navy's commitment to cutting-edge defense capabilities. Overview of Helios. Helios is engineered to bolster the U.S. Navy's defensive capabilities primarily against modern threats including unmanned aerial vehicles, UAVs, fast attack boats, and short-range missiles. The system operates at an initial power level of 60 kilowatts with the potential to be upgraded to 120 kilowatts depending on operational requirements. One of the key advantages of Helios is its virtually unlimited firing capacity provided there is sufficient power, which alleviates logistical challenges associated with conventional munitions. Additionally, the system includes an optical dazzler that can temporarily blind or disable enemy surveillance sensors, further enhancing its strategic utility. Development timeline. The development of Helios has been a methodical process. 2018, the U.S. Navy awarded Lockheed Martin a $150 million contract for the development of Helios systems. 2020, the project successfully passed its critical design review, allowing for further integration and testing. 2021, the USS Preble became the first Arleigh Burke-class destroyer to integrate the Helios system during sea trials conducted at Wallops Island, Virginia. 2023 to 2024, the U.S. Navy conducted extensive testing, including 32 test events focused on countering UAVs and other aerial threats. Integration with existing naval systems. The Helios system is integrated with the Aegis combat system, which enhances the operational effectiveness of the Navy's defense mechanisms. This integration signifies a strategic evolution towards creating a more cohesive and adaptable defensive framework within the U.S. Navy, allowing for better coordination between various defensive measures. Testing and performance. The U.S. Navy's Center for Countermeasures (CCM) has overseen numerous demonstrations of the Helios system where it successfully engaged unmanned aerial targets. These rigorous tests validated the system's functionality and operational performance, ensuring it meets the Navy's requirements for modern naval warfare. The successful engagements during testing underscore the system's potential as a reliable tool for countering emerging threats. Global context and competition. The deployment of Helios on the USS Preble reflects a broader trend in naval warfare, with multiple nations investing in high-energy laser technology. Notable competitors include Israel's Iron Beam, designed to intercept drones and rockets at a reduced cost per engagement. South Korea's Block I system, aimed at countering UAVs and other aerial threats. China and Russia both advancing their own directed energy weapon programs, indicating a growing global competition in this realm. The international race to develop and deploy high-energy laser systems highlights the strategic shift towards more cost-effective and sustainable defense solutions as nations adapt to evolving threats in asymmetric warfare scenarios. Conclusion. The integration of Helios aboard the USS Preble marks a significant milestone in the evolution of naval warfare technology, promising to redefine combat strategies at sea. With the potential to alter the dynamics of future conflicts, this advancement not only enhances the immediate operational capabilities of U.S. naval forces but also signals a pivotal shift in defense technology and strategy. As the U.S. Navy continues to refine Helios, the implications for naval warfare and international military competition are profound. With the global race for directed energy weapons intensifying. 1. Unlimited firing capacity. The Helios laser weapon system offers a virtually unlimited firing capacity as long as power is available, which is counterintuitive because many traditional weapon systems rely on finite ammunition supplies. This capability significantly reduces logistical burdens associated with resupply, altering the dynamics of naval operations during extended missions. 2. Integration with Aegis combat system. the Helios system's integration with the Aegis combat system showcases a move toward more interconnected defensive capabilities. This is counterintuitive in the sense that while many modern military systems focus on standalone capabilities, Helios emphasizes synergy among different systems to enhance combat effectiveness. 3. Dual capabilities. Helios is designed to perform both hard kill, physically destroying a target, and soft kill, disrupting or disabling enemy systems functions. This dual capability is counterintuitive because traditional weapons typically specialize in either destruction or disruption. But Helios combines both into a single system. For cost efficiency, the deployment of Helios is part of a broader military strategy aimed at developing cost-effective defense solutions. This is counterintuitive to the perception that advanced technology is always expensive. Instead, Helios aims to provide a less costly alternative to conventional missile defense systems. 5. Global competition in laser technology. The emergence of Helios coincides with a global race in directed energy weapons, which includes advancements from countries like Israel, China, and Russia. The counterintuitive aspect here is that while the US is a leader in laser technology, it faces significant competition from nations that are rapidly developing their own systems, suggesting that the technological landscape is more collaborative and competitive than previously thought. 6. Testing and atmospheric challenges. Critics highlight that despite Helios's advanced capabilities, challenges remain, particularly regarding power generation and atmospheric conditions impacting laser effectiveness. This is counterintuitive because one might assume that a laser system would be less affected by such variables compared to conventional weapons, yet environmental factors can significantly influence its performance. 7. Potential for space warfare. The discussion around Helios and similar systems includes considerations for space warfare capabilities, as mentioned in the context of Russian developments aimed at anti-satellite functions. This is counterintuitive in that traditional naval weapon systems are rarely viewed in the context of space, indicating a shifting paradigm in military strategy that encompasses multi-domain operations beyond just naval engagements. 8. Sustainability of defense solutions. The emphasis on high-energy laser systems like Helios points to a strategic shift toward more sustainable and versatile defense solutions. This is counterintuitive because it challenges the conventional notion that advanced military technology is inherently less sustainable due to reliance on complex supply chains for munitions. 9. International collaboration and innovation. The involvement of multiple nations in developing laser technologies suggests a trend toward international collaboration in defense innovation, which is counterintuitive to the traditional view of military technology being closely guarded and competitive, often leading to isolated advancements rather than shared knowledge and progress. 10. Long-term strategic implications. The integration of Helios is seen not just as an enhancement of current capabilities but as a potential game-changer in future naval warfare strategies. This is counterintuitive because it suggests that the introduction of a single system can fundamentally alter the nature of naval engagements, challenging established doctrines and operational methods that have been in place for decades. Significant overlooked aspects of Helios on USS Preble. The unveiling of the Helios high-energy laser with integrated optical-dazzler and surveillance laser weapon system on the USS Preble DDG-88 is a monumental development in naval warfare technology. While much of the coverage has focused on the capabilities and specifications of the system, several critical elements are often understated or overlooked. Yet they are of paramount significance to the future of military operations. 1. Unlimited firing capacity and logistical implications. One of the most revolutionary aspects of Helios is its virtually unlimited firing capacity contingent upon available power. This feature is significant not just for the immediate tactical advantages it offers but also for the broader logistical implications it entails. Traditional munitions require extensive supply chains for resupply, which can be vulnerable during operations. The Helios system, however, allows naval vessels to engage targets without the constant need for ammunition resupply, which could redefine naval strategy, particularly in extended operations or during blockades where resupply is challenging. The implications of this are profound. it allows naval forces to maintain a continuous defensive posture, reduces the vulnerability associated with logistics, and could potentially lead to a more agile and responsive naval fleet. This shift could change how naval engagements are planned and executed, as commanders may no longer need to consider ammunition constraints in the same way. 2. Integration with Aegis combat system. The integration of Helios with the Aegis combat system is a point often mentioned but not fully explored in terms of its implications for operational synergy. The Aegis system is already renowned for its advanced capabilities in missile defense and target tracking. By integrating Helios, the Navy enhances its defensive measures, enabling a multi-layered approach to threats ranging from drones to missile attacks. This integration signifies a strategic evolution where different systems can work in concert, leveraging the strengths of each to create a more formidable defense. It also sets a precedent for future weapon systems, suggesting that the Navy may prioritize interconnectedness in its technological advancements, leading to more sophisticated and effective combat strategies. 3. Soft kill capabilities and strategic reconnaissance. Helios's dual functionality, capable of both hard kill destruction of targets and soft kill disabling enemy sensors, is often noted, but the strategic implications of this capability are profound. The ability to blind or disrupt enemy surveillance and reconnaissance systems can significantly alter the dynamics of naval engagements. In modern warfare, information dominance is critical. The capacity to temporarily disable enemy sensors not only protects naval assets but also allows for more aggressive maneuvers without the risk of being detected. This capability could enable the U.S. Navy to conduct operations with greater stealth and surprise, potentially leading to advantages in both offensive and defensive scenarios. 4. Global competition in directed energy weapons. The Helios system's introduction is just one part of a larger global trend toward directed energy weapons. While the U.S. is at the forefront with Helios, other nations are rapidly developing their own systems, such as Israel's Iron Beam and South Korea's Block I. Understanding the global context is crucial. As nations invest in similar technologies, the competitive landscape of naval warfare is shifting. This arms race in directed energy weapons may lead to new doctrines and strategies as countries seek technological superiority. The implications for international security dynamics are significant, as advancements in one nation could compel others to accelerate their own programs, potentially leading to an arms race that extends beyond traditional weapon systems. 5. Challenges in atmospheric conditions and power generation. While the capabilities of Helios are impressive, the challenges associated with its effectiveness in real-world conditions are often glossed over. Laser systems can be affected by atmospheric conditions such as fog, rain, and dust, which can diminish their effectiveness. Furthermore, the need for substantial power generation to sustain high-energy operations poses logistical challenges, particularly for ships operating in contested environments where power availability may be limited. The Navy is recognized as actively working on solutions to these challenges, but the potential operational limitations introduced by environmental factors and power constraints are critical considerations for the effective deployment of Helios. 6. Cost-effectiveness and future military spending. The economic implications of the Helios system also warrant attention. Although the initial development costs are substantial, the potential for lower operational costs compared to traditional munitions could lead to significant long-term savings. As militaries globally face budget constraints, the ability to deploy cost-effective solutions without sacrificing operational capability is increasingly important. The shift towards directed energy weapons like Helios could represent a significant change in how military budgets are allocated, possibly prioritizing research and development into advanced technologies over traditional arms procurement. Conclusion. The integration of Helios aboard the USS Preble is not merely a technological advancement, it represents a significant shift in naval warfare paradigms. The overlooked aspects, logistical advantages, integration with existing systems, soft kill capabilities, global competition, real-world challenges, and economic implications, are critical to understanding the full impact of this development. As the U.S. Navy continues to refine and deploy Helios, the ramifications for naval strategy, international relations, and military doctrine will be profound, heralding a new era in maritime defense. 4 valuable points for in-depth analysis and discussion on Helios laser weapon. 1. Technological advancements and capabilities of Helios. The Helios high-energy laser with integrated optical-dazzler and surveillance system represents a significant technological leap in naval warfare. Its capabilities include a high-energy laser that can operate at an initial power of 60 kilowatts with potential upgrades to 120 kilowatts. The system is designed to engage multiple types of threats, including unmanned aerial vehicles, UAVs, and fast attack craft. The virtually unlimited firing capacity, as long as power is available, presents a paradigm shift from traditional munitions, allowing for sustained defensive operations without the logistical constraints of resupplying ammunition. This ability to engage targets with precision and speed positions Helios as a versatile tool in modern naval engagement scenarios. 2. Integration with existing naval systems. The integration of Helios with the Aegis combat system is a crucial aspect of its operational effectiveness. Aegis, known for its advanced missile defense capabilities, enhances the Helios system's functionality by providing seamless coordination with other defensive measures. This interconnectedness not only improves the overall combat readiness of the ship but also allows for a layered defense strategy, combining both hard kill destruction of targets and soft kill disruption of enemy sensors capabilities. Such integration signifies a strategic evolution in naval defense, emphasizing the necessity for multifaceted approaches to countering modern threats. 3. Global context and competitive landscape. The deployment of Helios aboard the USS Preble is part of a broader trend wherein multiple nations are investing heavily in directed energy weapon systems. Competitors like Israel's Iron Beam, South Korea's Block I, and advancements from nations like China and Russia highlight the intensifying global competition in this domain. This context raises questions about the implications for international naval strategy and security dynamics. As countries develop their own high-energy laser systems, the balance of power at sea may shift, necessitating adaptations in military strategies, alliances, and defense budgets. 4. Challenges and future directions. Despite the promising capabilities of Helios, challenges remain in its deployment and effectiveness. Issues surrounding power generation, atmospheric conditions affecting laser performance, and the need for enhanced shipboard power systems to support high-energy demands are critical considerations. The U.S. Navy acknowledges these hurdles and is actively pursuing solutions to ensure the reliability and effectiveness of laser systems in various operational scenarios. Furthermore, the ongoing development plans for scaling up to higher power systems such as the 150 kilowatt laser weapon system demonstrator suggest a future where directed energy weapons become a staple in naval arsenals, thereby redefining the standards of maritime defense. Conclusion. The introduction of the Helios laser weapon aboard the USS Preble marks a transformative moment in naval warfare technology. The interplay of its advanced capabilities, integration with established systems, the competitive global landscape, and the challenges ahead provides a rich framework for discussion. As militaries worldwide adapt to the evolving nature of threats, the implications of such advancements on future conflicts and strategic military planning warrant thorough examination. 1. The USS Ponce and the laser weapon system laws. In 2014, the USS Ponce became the first U.S. Navy ship to deploy a laser weapon system known as the Laser Weapon System laws. This system was developed to counter small boats and UAVs, and it operated at a power level of approximately 30 kilowatts. The laws demonstrated the ability to destroy targets with precision using an extremely focused beam of light, showcasing the potential of directed energy weapons in naval warfare. The deployment of LAWS on the USS Ponce marked a significant step toward the integration of laser technology in military operations, much like the current advancements with the Helios system. 2. The Israeli Iron Beam. Israel has developed the Iron Beam, a high-energy laser system designed to complement its Iron Dome missile defense system. The Iron Beam is intended to intercept short-range threats such as rockets, mortars, and drones at a significantly lower cost per engagement compared to traditional missile systems. The system operates using a high-powered laser to target and destroy incoming projectiles, emphasizing the growing role of laser technology in modern defense strategies. The Iron Beam represents a strategic asset for Israel as it adapts to evolving threats, paralleling the U.S. Navy's efforts with Helios. 3. The UK's Dragonfire laser system. The United Kingdom is actively developing the Dragonfire laser weapon system, which aims to provide advanced capabilities for countering aerial threats including drones and missiles. With an initial power output of 50 kilowatts, Dragonfire has undergone successful trials demonstrating its ability to engage and destroy targets with precision. The focus on integrating laser technology into the UK's military arsenal reflects a broader trend among nations to enhance their defense capabilities through innovative solutions. Similar to Helios, Dragonfire signifies a shift towards more sustainable and effective methods of warfare in response to modern threats. Future outlook: predictions for the USS Preble DDG-88 and Helios laser weapon system. The recent unveiling of the Helios high-energy laser with integrated optical-dazzler and surveillance system aboard the USS Preble DDG-88 marks a significant turning point in naval warfare, as the U.S. Navy integrates laser weaponry into its fleet. The future of naval combat will likely evolve dramatically. Here are predictions for how this technology may shape naval warfare over the next decade and beyond. 1. Expansion of directed energy weapons in naval fleets. As the Helios system demonstrates its effectiveness in trials, the U.S. Navy is expected to roll out similar or even more advanced directed energy weapon systems across a broader range of vessels. The integration of higher power systems such as the 150 kilowatt laser weapon system demonstrator LWSD will likely see deployment on aircraft carriers and amphibious assault ships, enhancing their defensive capabilities against emerging threats. 2. Increased operational flexibility. With Helios providing virtually unlimited firing capacity, naval vessels will have greater operational flexibility. Ships will be able to engage multiple threats without the constraints of traditional ammunition logistics. This shift will allow for prolonged missions in contested environments, where resupply may be difficult. The ability to operate continuously against aerial threats will also change how naval commanders strategize during engagements. 3. Integration with autonomous systems. Future developments may see Helios integrated with unmanned aerial vehicles, UAVs, and autonomous defense systems. This could create a synergistic effect where UAVs can conduct reconnaissance and target identification while Helios provides a robust defense mechanism. Such integration will likely enhance situational awareness and response times, allowing for rapid engagement of threats. 4. Advancements in laser technology. As research in laser technology continues, we can expect innovations that enhance the effectiveness of systems like Helios. Improvements in power generation, cooling systems, and atmospheric performance will increase the range and accuracy of laser weapons. Additionally, advancements in artificial intelligence could enhance target acquisition and engagement capabilities, allowing for faster and more precise responses to threats. 5. Global arms race and directed energy weapons. The introduction of Helios will likely spur an international arms race in directed energy weapons. Countries such as China, Russia, Israel, and South Korea are already investing heavily in similar technologies. This competition may drive further innovation and development, leading to more sophisticated systems capable of addressing a wider array of threats, including aerial, surface, and even space-based targets. 6. Shifts in naval combat strategy. The integration of directed energy weapons will necessitate a re-evaluation of naval combat strategies. Traditional concepts of naval warfare, which heavily rely on kinetic weapons and missile systems, may evolve to incorporate a mix of laser systems and electronic warfare capabilities. This hybrid approach will offer commanders more options in countering diverse threats effectively. 7. Enhanced cyber and electronic warfare integration. Future naval engagements will likely see an increased emphasis on cyber and electronic warfare capabilities alongside laser systems. The optical-dazzler component of Helios, which can blind enemy sensors, represents just one aspect of this trend. As laser systems become more prevalent, the need for comprehensive cyber defenses and offensive capabilities will grow, further complicating naval engagements. 8. Cost-effectiveness and resource allocation. The cost-effectiveness of laser systems, which can engage targets at a fraction of the cost of traditional munitions, will shift resource allocation within naval budgets. As investment in directed energy weapons increases, we may see a reduction in conventional arms procurement, leading to a transformation in how naval forces are equipped and operated. 9. Legal and ethical considerations. The deployment of high-energy laser systems will bring about new legal and ethical considerations in warfare. As these systems gain prominence, discussions around the rules of engagement, accountability for autonomous systems, and the implications of non-lethal capabilities will become critical. International norms and regulations may evolve to address these concerns. 10. Transformation of naval warfare training. With the introduction of advanced systems like Helios, naval training programs will need to adapt. Future training will focus on the operational use of directed energy weapons, including tactics for integrating them with existing systems and coordinating with other branches of the military. This evolution will require a rethinking of doctrine and operational procedures. Conclusion. The Helios laser weapon system aboard the USS Preble represents a paradigm shift in naval warfare. As this technology matures and becomes more prevalent, it will transform operational capabilities, strategic approaches, and the international defense landscape. The next decade will be critical as nations adapt to these advancements, shaping the future of naval combat and defense strategies globally. The implications of Helios and similar systems will resonate far beyond the battlefield, influencing geopolitical dynamics, military collaborations, and the nature of warfare itself.